A rectangular coil rotates at a constant angular velocity. At the instant shown, the plane of the coil is at right angles to the line ZZ primed. A uniform magnetic field acts in the direction YY primed. The variation of EMF with time is shown. What coil rotation about the axis specified produces this graph? So it is given that magnetic field lines are vertical, and if you rotate about YY primed, there will be always no lines cutting the coil, and there will be no change in number of lines cutting the coil, so there will be no change in the magnetic flux, so there will be no induced EMF. Or using a formula that the magnetic flux is the magnetic field strength B times area times cosine of the angle between B vector and normal to the coil. And you can see that there will be always 90-degree angle between B vector and normal, and cosine of 90 degrees is 0. But when you rotate about XX primed, you can see that there will be a different number of lines cutting the coil and different moments of time. And initially, the magnetic flux is 0 because no lines cutting the coil, or using this formula, the angle is 90 degrees, so cosine is 0. It means that the magnetic flux is 0, and we know when the magnetic flux is 0, EMF has its maximum by amplitude, or by the absolute value. And when it is rotated through pi over 2, the magnetic flux becomes maximum, because angle becomes 0, cosine of 0 is 1, or when B is perpendicular to the coil, it gives us the maximum possible lines cutting the coil, so the magnetic flux has its maximum value and the induced EMF is 0. So it should be rotated through pi over 2. If it would be rotated through pi, a graph would look like this. The magnetic flux becomes 0 when it is rotated through pi, and EMF has its maximum by amplitude, by the absolute value, but it will be negative. So through pi over 2 about XX primed. So it's A, and that's all for this question.